So what we're going to go over next is the parabola, and we have two types of parabolas, we could say, okay, or I should say two standard forms. We have y equals a times x minus h quantity squared plus k. Okay, this is what we are familiar with, okay, also known as vertex form. The vertex is h comma k, and when a is greater than 0, this is a u that faces up. When a is less than 0, this parabola is a u that faces down. The other formula that you're not as familiar with is x equals a times y minus k squared plus h. Now be very careful. The y coordinate of the vertex is with k, and notice k is the change in y. Okay, so the vertex is still h comma k here. But be very careful. H is just what's sitting out here. K is what makes this 0. Okay, so when a is greater than 0, you're actually a u, sideways u that opens to the right. When a is less than 0, that means all your values would be falling. Your output values would be falling. You notice the outputs are x, so that's why x is getting more and more negative. X is getting more and more positive because a is greater than 0 there. Okay, so before we start graphing, there's something I want to mention to you. There's something called the focus and the directrix. Now, these have to do with how you're actually making the shape of the parabola, that parabolic shape. So when you have a parabola that looks like this, okay, there's our vertex. The focus is actually inside here, and the directrix is actually a horizontal line outside here. Now, this distance from the vertex to the focus and from the vertex to the directrix, okay, that's called that point right there is called the focus, and this horizontal line is called the directrix, okay. These lengths are equal, okay. This length right here is equal to this length. So the relationship, this parabolic shape, has to do with the distance from the directrix, okay, and the focus hitting. Okay, that's how we're actually making this parabolic shape. And if you had a parabola facing this way, okay, here's your vertex. This would be the focus, and this would be the directrix. Okay, and these two lengths from the vertex to the directrix and from the vertex to the focus are equal. Okay, same as over here. If this was our parabola, that's the focus, okay? This would be the directrix. Notice this time the directrix is a vertical line. The length there is the same as that length there. And if we opened this way, okay, here would be the focus. Oops. Also called the focal point, okay? The directrix would be right here. Notice it's a vertical line. Vertex to focus, the same length as vertex to directrix. And the distance to get from the vertex to the directrix or to the focal point, okay, is the absolute value of 1 over 4a, okay? So what you'll have to name is the equation of the directrix as well as the focal point. What we're going to be doing when we sketch these parabolas, we want to make sure the vertex is correct, that we have the right orientation, that we have the right focal point, and we have the right directrix. So we're going to practice one of each, and then we'll do a third problem, and that will be it for parabolas. Okay, so we see that we're here in vertex form of a parabola. So what we want to do is we want to pull out the vertex. Now the vertex is h comma k. Change in x, so the change in x is -4. And then this would be k, -5. And now let's worry about its orientation. So that's all about right there, okay? Is a greater than 0 or less than 0? It's greater than 0. Now, this is also be mindful of this. This is when x squared, okay, is the quadratic term. Okay? When x squared is the quadratic term and y does not have the quadratic term, this is when we either open up or we open down. That's what we're used to. Okay? So what this is saying is our outputs, okay, as we plug in values for x, okay, our outputs are either going to grow or they're going to get smaller. Okay, now it all depends on a. If a is greater than 0, that means that this is a u that faces up. Okay, so all I need is for you to have 1, 2, 3, 4, 2, 3, 4, 5. Okay, I just need you to have the right orientation. So this is going to be a u that faces up. Now, where will the focal point or the focus be? The focus is inside. So remember, to get from the vertex to the focus, that's the absolute value of 1 over 4a. So 1 over 4a, a is 2. So this is the absolute value of 4 times 2. So it's going to be the absolute value of 1/8. The absolute value of 1/8 is 1/8. So I have to go up, okay, because the focus falls inside. So the focus is going to fall up 1/8 of a unit. So the focal point, okay, the x coordinate isn't changing at all. And what do you have to add to the y coordinate? 1/8. So the focal point is the point -4, comma, -4 7/8. It's just 1 unit, 1/8 of a unit up. Okay, that's the focus. We just put an F there. Okay, now the directrix is going to be the horizontal line that falls down here. Okay, now that is also the same distance away, but it's going to be below it. So that's going to be the line. Okay, if that's -8, if that's -5, we're dropping an eighth. So that's going to be -5 and 1/8. And that's the directrix. And so that's all you have to do. Make sure you have the vertex, the correct orientation, the focal point, and the directrix. Next up, we have x equals -2 times the quantity of y minus 3 being squared, minus 3. Notice it's a parabola, and notice this time y is being squared, okay, and x is the term that doesn't have a quadratic term. That means this either is going to open to the left or it's going to open to the right. So first, let's get the vertex. Now remember, h, k. H is right here, -3. Now, it's the change in y is k. So if this is y minus 3, what makes this 0? 3. So the vertex here is -3, 3. And what is a? A here is -2, so it's less than 0. That means that this is going to open to the left. Okay, so it's going to open like this. The focus sits inside of the parabola, so it's going to sit somewhere over here. So to get it, okay, we need to worry about, that's the distance from the vertex to the focus and to the directrix. So that's going to be 1 over 4 times -2. So that's going to be the absolute value of -1/8, which is 1/8. Okay, but notice this time, the focus falls to the left. Okay, so the focal point, or the focus, okay, it's to the left. So I have to take away 1/8, and the y-coordinate stays the same. So it's -3 and 1/8, comma 3. Okay, it's going to be just a little bit in. And now the directrix is going to be a vertical line. Okay, so x equals, and it's going to be to the right by 1/8. So if that x-coordinate is -3, okay, to the right by 1/8, means that's going to be -3 plus 1/8. So that's going to be x equals -2 and 7/8. So it's very close. Okay, and that would be the directrix. Okay, and we'll do one more problem. And then that is it for the parabola. So we're going to sketch x plus 3y squared plus 12y equals 18. So the first thing, let's put it in general form of the conic. So that's going to be x plus 3y squared plus 12y minus 18 equals 0. So we're going to check out what conic this is. So let's look. We have one quadratic term, so we know that this is a parabola. So remember, whichever is the letter that's not the quadratic term, so x, that means we want all of the other terms on the other side. So x equals negative 3y squared minus 12y plus 18. So what we're going to want here is to make sure that we complete the square with the right-hand side. So that's not the value I want there. So I'm going to take away 18 from both sides. So that's going to give me x minus 18 equals negative 3y squared minus 12y. So I need to complete the square on the right-hand side. Whatever I add into the right, I need to make sure I'm adding into the left. Now I can't start completing the square until the coefficient on my quadratic term here is 1. So I have to factor out that negative 3. Now the coefficient on the quadratic term is 1, so I'll be able to complete the square inside the parentheses. If I factor out a negative 3, this becomes plus 4y. So half of 4 squared is 4, but I didn't really put in 4. I put in negative 12. Okay, so this is going to be x minus 30 equals negative 3 times, write this as a square binomial, y plus 2 squared. Okay, add 30 to both sides, and we've got x equals negative 3 times y plus 2 squared plus 30. Okay, so here's the equation in vertex form, or standard form. It allows you to graph. So notice the y squared is the quadratic term. That means this is either going to open left or it's going to open to the right. Well, a is negative, so it's going to open to the left. Okay, so let's get the vertex. Okay, so the vertex, remember, h comma k, this is h, 30. K, what makes this 0? Negative 2. Okay, so let's go by 5s on the x-axis. We'll go by 1 on the y. 10, 20, 30, 30, negative 2. A bit skewed, but that's okay. Otherwise, we won't be able to fit. Okay, and so this opens to the left. And so we need the focus. So let's think about what's the absolute value of 1 over 4a. That's the distance. Now the focus, remember, is going to be inside the parabola. And so the directrix is going to be outside. Okay, that's 30, so that's 35 there. So this is going to be 1 over 4 times negative 3. Okay, so that's going to be 1 over negative 12. Okay, so the distance is 1/12. The absolute value of negative 1/12 is 1/12. So the focus is going to be to the left by 1/12 of a unit. So 1/12 to the left of the vertex, okay, that's 30 minus a 12th. So that's 29 and 11/12ths, comma negative 2. And then the directrix falls to the right by a 12th. So that's going to be the directrix. Notice it's a vertical line. Okay, so that's going to be x equals 30 plus a 12. So that's going to be x equals 30 and 1/12 is the equation of the directrix. Okay, so that's the information that you need to have for when you are graphing a parabola. Have its vertex, have the correct orientation, have the focal point, and the equation of the directrix, as well as all of that graph.